So let's look at the first page of chapter 6, just as a reference, because these keywords are going to be very important for you. So refer back to these as much as you need to. And let's get started. So what calculator command would you use to find the probability or area underneath the normal curve? This is going to be number 4. And then the calculator command to find the value of a normal random variable will be number 5. So anytime the question's asking for area or probability or the percent, this will be your indicator. Very, very important. Remember, a normal variable is what you're measuring. So are you measuring IQ, blood sugar levels, height, age? Okay, so that's how you know which one to use. So the length of a human pregnancy is normally distributed with a mean of 272 days with a standard deviation of 9 days. Let's state the individual variable, type of variable, and random variable X, and list the givens with the correct symbols. So first, what is the individual? This is the human pregnancy. What's the variable? The length in days. The type of variable. Is it quantitative or qualitative? It's quantitative. And it is continuous because you could have a day and a half, right? You can have a part of a day for the length of the pregnancy. And then the random variable, our random variable X is the length of a randomly selected human pregnancy. Part A, find the probability. So that's your keyword. You see that? Think number 4. So you want to find the probability of a pregnancy lasting greater than or equal to 272 days. So we have a mean of 272. We're wanting to look at 272 and greater. So right away, you probably know. That's an easy one, 0.5. Okay, so we know that should be 0.5. So let's make sure when we use number 4 in the calculator sheet, that is what we get. So let's go to 4 on our calculator sheet. Here, you're going to go to the Compute tab, then go to the Normal section, and then you're going to insert the mu, sigma, and lower and upper bounds. Now, it's going to be very important for you to draw this out because you get a visual of what the lower and upper bounds are going to be. We know the mean is 272. We know the standard deviation is 9. Now, what is your lower and upper? So the lowest value is 272, and we're going all the way up. So your upper value, when it's not known, you're just going to put a really large number in. So like 9999. This will just represent a really large number far to the right. If we had it to the left, you would use the lower bound as negative 999, and the upper is 272. So that is in your calculator sheet here as well. So when the lower is unknown, you can use negative 9s, and the upper use 9s. Okay, let's use the calculator sheet. So we're on the Compute tab, go to Normal. The mean is 272, standard deviation of 9. The lower bound is 272 all the way up. So 0.5 is the probability. And that's exactly what we thought it would be. To write this out, probability of X is greater than or equal to 272. It's going to equal 0.5. Greater than or equal to 272 is this part right here. And then this part's always the same. You start with. Okay, so start with probability of X. So we want to find the probability lasting more than 280 days. So greater than 280. Or less than 264. So let's draw this out. 272 is right here. You can kind of guess. So 280, let's just say 280 is here. We want greater than 280. We want 264 somewhere over here and somewhere less. Okay, so let's go to your calculator sheet. I would do one at a time. So 280 and above is 0.187. Now you might want to go out further depending on where you're supposed to round to for your final answer. And then 264 and less. So 264 is the highest number now, and you're going to go all the way down to a really small number. So 0.187 as well. So add those together, you get 0.374. We want to find the probability lasting at most 250 days. So again, I'd write 272 in here. And then just estimate where 250 is. This is just to help you where to shade. So 250, yeah, and we know it should be less than half, right? Because we're talking this part. So probability that x is less than 250. Now it doesn't matter if you put the equal to signs here or not, technically, because that doesn't make a difference since this data is continuous. So the upper value would be 250 and -9s. So just change that to 250 for the upper. So 0.007. Obviously, this is not good drawing. If you actually did the 9 standard deviations out, it'd be way over here, 250. Find the probability that pregnancy is between 265 and 280 days. So again, you got about 265, 280. So you want in between. So 265 is your lowest to highest. So you do 265 to 280. So 0.59. And let's write that out. X is greater than 264, but less than 280. So the interpretation of this is that 59%, there is a 59% chance that a randomly selected pregnancy will last between 265 to 280 days. Let me just type this out for you so you have this in your notes as well. So again, there is a 59% chance that a randomly selected pregnancy will last between 265 and 280 days. Next, let's find the length of pregnancy that 10% of all pregnancies last less than. Okay, so up above we were asked for probability. This is now asking for length. That is a variable, so you should be thinking number 5. So when we write this out, its probability of x is less than, this is the part we're looking for. We know it's equal to 0.1. So this is the value we want to know. The 0.1 is what would get you, or number 4 in the calculator sheet would be what would get you 0.1 if you knew this value. So again, 272, 263. So what value is going to be right here? So on the calculator sheet, it says we go to the compute tab, normal, and then the left area tail. Make sure the mean and standard deviations are inputted under the normal area. So compute, normal, left tail. Make sure these are entered. You have to have those correct because this is calculating off of that. So area to the left, so you have to make sure it's to the left, is 0.1. So it's 260.5. So this is 260.5. Now, you could, if you wanted to double check, use number 4 and do 260.5. We've got negative 9 and 9 because it's to the left. 260.5, 10.10 or 10%. Suppose you meet a woman who says that she was pregnant for less than 250 days. Would this be unusual? And what might you think? So for us to figure out something's unusual, we need to figure out what the probability is. So look at part C because we already did it. Less than 250 days, 0.007. Is this unusual? Yes, it is. Because it is less than 0.05. So it is unusual. You would think that either the woman had a premature baby or that she may be wrong about when she actually became pregnant.